Hi, my name is Trey Hayden, and I wanted to spend some time today talking about a topic I don't see covered too much in the tutorial space for Unity, which is this notion of a planar raycast. And instead, to accomplish what I use the planar raycast for, beginners are typically asked to use this other function called camera.screen to world point, which is supposed to take a point on your screen and determine for you a corresponding position within the game world. And you can use this to click things and move characters, that kind of stuff. And so there's plenty of these like beginner-focused tutorials out there that evangelize for this function and use it and tell you how great it is and give you plenty of these fun use cases. And so as a beginner, you would see this and think, okay, great, this is actually pretty straightforward. But I don't really think that this function is good at all, and I don't use it in any of my personal professional projects because there's just kind of frankly too much magic going on. And if it doesn't work, you don't really have any levers to pull to help make it work. And so what I do instead, and we'll cover that here, is this notion of a planar raycast, and we'll see how that works. So what I want for this project is when my mouse hovers over these squares, I want it to turn yellow. And when the mouse is not in the square, I want it to turn gray. Pretty straightforward, not a huge set of requirements. So let's go ahead and implement that. So on the screen point one, do an update, and I'll get back to that in a second. So the first thing I want is just this function that determines whether or not my mouse is currently within the collider. So is mouse within collider. Camera that I want is just one of the arguments, and we'll take a collider 2D, which also be passed as our field up here, which we're going to get from the inspector. So the first thing we want is the screen position. Screen position. If you're doing the newer input system, I think it's mouse.current.position. Someone in the comments can check me if I'm incorrect on that one, but I was pretty sure that was it. And for this, I just want to make sure that I'm following exactly what beginners are told to do here. And so this is what this person is using. And this is how their apparently works. So let's just go ahead and use that. Up in our screen position. And then this should be, rename this to mouse world position to make it a little more obvious. So now I should be able to take this world position and use the actual camera that we provided in. And return whether or not this overlaps with our collider. World position. Okay. So this mouse collider. The camera.main. Pass in the collider we got from the inspector. And now this .sprite renderer.color equals is mouse within collider. Color.yellow if so. Color.gray if it's not. Okay, so according to this beginner-focused tutorial, is mouse within collider, we are using their function to get the mouse world position. Then we're using a built-in function to determine if the world position is within this 2D collider. We should be able to highlight the square on the left, and it should become yellow. But note that when we do this, it doesn't actually become yellow at all. It stays gray. If we change the camera to orthographic, this does suddenly work. But nowhere in this article does it mention that orthographic is a requirement. It seems to say, if you use this magical Unity function, you will get a world space coordinate relative to your screen position. This is one of the issues I have with this magical function. One of the reasons I don't use it. There are no real levers you can pull for this thing. It just kind of works in some contexts, and in others it doesn't seem to do anything. So, on the other hand, the alternative I want to present is this notion of a planar raycast. So I'm going to take all of this kind of stuff here, drop it here, got this function. We'll keep the screen position, that doesn't really change. And this stuff up here is also fine. So what we're going to do now is essentially construct a plane along the, don't worry about the error, along this XY sort of space. And what I want is for the camera to basically serve as the origin for a ray and I want it to strike this XY plane somewhere, and where it strikes it, that's where I'm going to take the physics check, right? I'm not going to use magic Unity stuff, I'm just going to use math, because math is much more reliable than random Unity stuff. So let's go back over here. I need to define this plane. The plane is, for those of you who didn't do a whole ton of math when you were growing up, plane needs two things. You either need 3 points, or you need a normal direction and a point on the plane. So in our case, let's just do the point on the plane in the normal direction. So plane position, slider 2D, the bounds, not bounciness, center. This should be, the center of a 2D collider should be on the plane we care about. We're checking this collider specifically. And plane correction is going to just be vector3.forward. You can also do vector3.back as long as it's a strictly z axis, because xy plane, that's what the normal would be. So we're going to define a plane now, new plane, plane direction, plane position. Okay. So once we have our plane defined here, we need to get a ray. This is the ray we wanted from the camera into the scene, based on where the mouse is on the screen. So mouse ray equals camera.screen point to ray. We're going to do the mouse screen position. And now we should have all of the information required to do this little math trick. So let's check. Mouse hit plane. Now this is the weird part. We're going to do plane.raycast. This is not physics.raycast. This is not capital P plane.raycast. This is an instanced raycast for this plane that we have created here. And it takes two things. We need a ray, the mouse.ray. And the next thing we use is this out variable. So if you've done normal raycasts before with the physics libraries for Unity, and usually you get either a raycast hit, a raycast hit 2D, it's cached somewhere, that kind of stuff. For the planar raycast, you get a distance. This is a float. For whatever reason, they have named it enter. This does not make sense to my brain, so I'm going to name it ray travel distance, because that's what's going on here. So if did mouse hit plane, we're going to get the world position of the mouse. Mouse world position is going to be the mouse ray where it started, plus mouse ray direction, so where was it going, times how far did it travel. So once we have this, then we just check, okay, does the collider actually overlap this world position? And if we didn't hit the plane at all for some spooky reason, just return false. So up here is the same, we didn't change anything there, we just changed how this function is calculated. So go back over here. Okay, as we see, we're still in perspective mode, so this one on the left doesn't work, but magically, this one on the right works just fine. Go to our camera, it's back to graphic, this one still works, this one also works, but note that this one doesn't care what the camera is doing. It doesn't care about camera definitions, nothing spooky. So I want to sort of show how this one is working, just for a little bit of additional information. Let's do deep draw line. We're going to draw it from the mouse ray.origin, and we're going to draw it to mouse world position. Color.red. Let's do white. White would show up a little bit better on the background I've chosen. All right. Okay. So we're going to put the scene on the left, game on the right. Now note over here, let's go top down so you can kind of markedly see the white, it's sort of pointing right here. Note that it stops exactly on the XY plane, because that's where it struck the XY plane. I can go above these or below these, but as soon as I intersect this one on the right, it turns yellow. Similarly, if we look at it from x-axis, it still stops exactly along the XY plane, right? This is exactly where it has to strike. So there's no magic here. There's no built-in Unity stuff doing weird things behind the scenes that you have no control over. It's purely math. And so that's why I really prefer this approach versus the this one, the sort of screen to world point, because you have complete control over everything involved in this calculation. And you don't have to rely on project settings or what kind of camera got passed in or what is the near clip plane, any of that sort of stuff. you can just define it all explicitly, and you know it will work every time. So the other example I had for this was a 3D situation, where we don't really need the scene view, that's not super interesting, where I've got this little green guy here, and all the green guy wants to do is look at the mouse. So we're going to see what happens if I just use regular raycasting. So note that he does tilt a little bit upward when I touch these red blocks. So ideally he just sort of looks at the ground, and you can get rid of if you're asymptotic if you touch close to him. But I just want him to sort of keep looking at the ground. And you can solve this with physics layers. And so if I go over here to like the ground, for example, and say make a new layer, ground, and I only want this one to have that layer. Then I go to this thing that's actually doing the check, only check for ground, and then, voila, it works. But the issue you get with this kind of physics approach for something like, where is my player looking, is that if you don't actually touch anything with your raycast, note that he's actually not looking anymore, because this check requires there to be some sort of contact with an object in the scene from the camera. And if there isn't, then what is it supposed to look at? This is basically an undefined point. But when I use the planar setup, this doesn't happen. Because in this case, rather than do the XY plane for a 2D context, I'm using the XZ plane for where the player can move. And so it doesn't matter if I've struck collision or if there's a renderer in the way or what my physics layers are. I know that for sure, if I turn gizmos on, I can always pick a point on this plane because I know for sure that the camera is looking at it as far as the mouse is concerned. So again, when I go back to regular, like I get this here, but if I touch like the side of something, note he starts to lean a little bit. So this might not be behavior you want. And you would have to adjust for this by saying, okay, well, whatever I hit, zero out the Y component, the Z component, or whatever happens to be the vertical for your situation. But you still have to account for this manually. Whereas in a planar context, you simply don't, it just works every time. So that's what I wanted to cover today. Obviously, with the raycasting stuff, and even with the planar stuff, more involved projects, you might have extra considerations to account for. But for me personally, for side projects and my work in a professional context for studios, like I think planar raycast is such a simple solution for many of these kinds of problems. And again, I didn't see too many people talking about it, so I wanted to make a short video to discuss it. So again, if you're a beginner, I think this is a great approach for doing mouse stuff. And even if you've been involved a little bit longer and you didn't know about this, I hope it was a little bit educational. But otherwise, I hope you have a great day and best luck in your games. Bye all.